All right, so here's the starter. We've got a 16-volt battery, and it's pushing 2 amps of current through 2 resistors. One of the resistors we know is 4 ohms. The other one we don't know. And so what we want to find is, how much did the voltage change going across R1? Like if you jump from here down to here, how much did the voltage change? That's what the delta V means. Delta means change, the change in voltage. And then what was the change in voltage across from here to here? And then if we know that, if we know delta V and we know that 2 amps is flowing through it, we can figure out the resistance of that resistor. And then let's calculate the total power. And then I'm going to show you something else that I didn't ask you to do, but so let's solve it. Well, if I want to know delta V, we know Ohm's law. Ohm's law says, well, there's several ways of writing Ohm's law. You can use a triangle if you want, V, I, R, like that. And what are we trying to find here? We're trying to find the change in voltage, so it's just I times R. So the voltage, we can say delta V1, the change in voltage across the first resistor is the current through it, 2 amps. Well, actually, let me be thorough with good technique. That is, we write the formula down, and then we'll plug in our numbers. 2 amps times 4 ohms. Remember that an ohm is a volt per amp. So we have a volt per amp there. That amp cancels with the amps, leaving volts. 2 times 4 is 8. So delta V1 equals 8 volts. And that's your answer for A. Now your answer for B is this. Look, I know that when I go from here to here, I have to gain 16 volts. I mean, the battery delivers 16 joules of energy to the electricity for every coulomb of electrical charge that flows through it. So when I go from here to here, I have to lose 16 volts. So the voltage gained has to be equal to the voltage lost. So that's going to be equal, the voltage lost, or the voltage that you jump down through, is the voltage drop across R1 and R2. So I'm just going to write it like this. Now you probably didn't do that. That's okay. I just am explaining it a little bit differently, that I know that when I go from here down to here, it has to add up to 16 volts. Now that tells me that delta V2 is equal to 16 volts minus delta V1. And that is going to be 16 volts minus 8 volts. So delta V2 equals 8 volts. And that's your answer for part B. So I didn't really mean to do that when I made up this problem. I should have picked a different, like maybe 12 volts or something. But we dropped 8 volts, and then we dropped 8 volts. Because we gained 16, so we have to lose 16 when we're going in a circle. Okay, does that make sense to everybody? I hope. All right, now part C. We want to know what R2 is. Well, what is Ohm's law? Here it is. R equals V divided by I. That is, the resistance of a resistor, R2, is equal to delta V, for 2, over the current. Now, we know what the current is. The current is 2 amps through everything, because there's only one path. There's only one loop here. So everything's got 2 amps of current flowing through it. But R2, and that includes the second resistor, so it's got 2 amps. And we know what the voltage drop is across here. That's going to be 8 volts. 8 divided by 2 is 4. And a volt per amp is an ohm. So R2 is equal to 4 ohms. Yes? Does that make sense? Okay, now let's do part D. What is the total power? Well, you can think of it in 2 ways. What's the power that is entering, at what rate does the battery deliver energy to the circuit? But all that energy has to go somewhere, right? It has to go somewhere. You have to conserve energy. So some of the energy leaves these resistors. Now, what are these resistors? I don't know. Light bulbs, motors, actual electronic resistors. I don't know. It doesn't matter. I'm just going to say how much energy is delivered by the battery. We know that power equals I times E, or sometimes we'll write it power equals I times V, depending on whether you're using this variable name or this variable name. You see both of them out there. So this is just 2 amps times 16 volts, and 2 times 16 is 32. And an amp, remember, an amp is a coulomb per second, and a volt is a joule per coulomb. So if you break an amp times a volt down, the coulombs will cancel, and I get a joule per second, and a joule per second is a watt. So the power is equal to 32 watts. One thing you can also do is figure out, I'm not going to go there. This resistor is putting out 16 watts of power, and this resistor is putting out 16 watts of power because they have the same current, same resistance, same voltage drop. So, but anyway, there you go. And this is the kind of problem I'm going to put on a quiz, and I've been threatening to give you a quiz for a long time, and I'm going to do it. So pay attention to this, and this will be on the website, so if you want to study what I just did, you can certainly do that. That is all.